Hello to the video, Vectors in Two-Dimensional Space Part 1. In this video, we take care of the basics of vectors in two-dimensional space. Here we describe the vector A, which is drawn in purple. Vectors can be specified in the coordinate notation. In two-dimensional space, two vector components are required to describe a vector. These vector components are identified either with the indices 1, 2 or with x, y, and written down in columns. The vector component with the index x describes the position of the vector in two-dimensional space in the direction of the x-axis. In this example, the value 4 was chosen for the x component. The x component is plotted in the Cartesian coordinate system in the direction of the x-axis. The vector component, with the indication y, describes the position of the vector in two-dimensional space, in the direction of the y-axis. In this example, the value 7 was chosen for the y component. The y component is plotted in the Cartesian coordinate system, in the direction of the y-axis. The starting point of the x component, and the ending point of the y component, describe the vector A, in the Cartesian coordinate system. The x component, and y component, can also be interchanged in the Cartesian coordinate system. The length of the vector is also called the amount. Therefore, the y vector component is at right angles to the x vector component. The vector components together with the vector form a right triangle. With the help of the Pythagorean theorem, we can calculate the magnitude of the vector. Already converted here, to calculate the amount A. The angle of the vector to the x-axis can also be calculated by using trigonometric functions. If the amount of the vector has not been calculated, one can use the arctangent function, which is the reciprocal of the tangent function. If the amount of the vector is known, the arcsine function, which is the reciprocal of the sine function, can be used to calculate the angle of the vector to the x-axis. Likewise, you can use the arccosine function, which is the reciprocal of the cosine function, to calculate the angle of the vector to the x-axis. Of course, the opposite way is also possible. Thus, one can express the x and y vector components by means of the sine function and the cosine function. A vector can be described in the polar coordinate system by means of the angle and amount.
Thank you.